Hi, I'm Brian Lasser, president of Xenix Software, where we're focused on reducing the cost of software testing by making testers more productive. One of the most fundamental reasons why organizations may not be getting the most from their investment in test automation is in the choices that they make when deciding what and what not to automate. Yet those choices are critical success factors. In this presentation, I'll provide guidelines for making the right choices to ensure that your next automated testing project gets off to a good start. In part 1 of this presentation, we reviewed the reasons that we automate tests in the first place and then compared the efficiency and effectiveness of manual and automated testing. In part 2, we'll evaluate automation candidates to provide some experience on how to prioritize tests for automation. Ultimately, your level of experience with test automation should dictate what types of tests that you attempt to automate. But regardless of your experience, it's always best to give a higher priority to tests that can be automated quickly and easily because the organization gets the benefits right away. Each target application will offer its own unique reasons for automating or not automating a set of tests, but there are some rules of thumb that can be applied. Let's look first at the qualities of poor automation candidates. Long, complex transactions with a lot of navigational steps should be given a lower priority because they will likely require more maintenance. Likewise, test procedures that span multiple applications or those that require external data feeds will also require more sophisticated techniques to insulate them from changes in the test environment. Timing can be a factor as well. When a feature is first developed, it might be frustrating to automate if the transaction flow is constantly changing. Building robust verification steps is typically the biggest challenge in test automation. When the results of a test are hard to predict, it is best to give them a lower priority. On the next few slides, we'll look at the types of tests that offer good candidates for test automation. We'll start with short, simple transactions and discuss test requirements that can be satisfied with universally reusable tests. We'll focus on the sweet spot, where we can reuse an automated test with many combinations of data. Finally, we'll identify tests where the results are either stable or easy to generate at runtime. One of the objectives of automated testing is to reduce the manual testing effort. To achieve those benefits right away, it makes sense to pick the low-hanging fruit, so short and simple tests should get the highest priority. Manual testers spend countless hours performing the types of tests that require very little domain expertise, like data type validations, field lengths, missing required fields, and data content validations like invalid passwords or records not found. I'm sure that you can think of many categories along those lines in your own applications. Any form-based application is going to require hundreds of the types of validation that I'm referring to. Take a look at the credit card application pictured here. It's a single form with hundreds of validation points. In addition to the types of tests that I just listed, you'll notice that this form contains several formatted fields, including email addresses, zip codes, phone numbers, and social security numbers. It also contains fields where the value is confirmed by inputting it a second time. Manual testers should not be spending time on these type of tests as they are among the quickest and easiest to automate. Tests can be designed so that they can be reused against any application. I refer to those types of tests as universal tests. They reduce maintenance to zero. Universal tests can be created to validate minimum and maximum field length, button size, tab order, and adherence to style guidelines, including, but certainly not limited to, validating that all labels end with a colon, or the existence of a close box on each dialog box, or the number of choices in a radio group. Here's an example of a universal test that validates that a given text field will truncate input to the specified field length. This test step takes two parameters: the identifier of the field to be tested along with the expected maximum field length. The automated test procedure creates a string that is equal to the expected field length of the field. It then adds one character and inputs that string into the field. It then verifies that the text field contains only the original string. If the field accepted the entire string, the verify action will raise an error. This step can be called for any field that behaves in this manner. It will never require maintenance because it's not dependent upon the target application in any way. One of the most important ways to reduce maintenance is to create reusable data-driven tests. This is the sweet spot of test automation, and opportunities for this type of test abound in almost every application. To identify opportunities to create data-driven tests, look for paths through the target application where there are lots of different data combinations. The reason why this is so important is that you'll spend relatively little time creating an automated test procedure that can be reused tens or hundreds of times with different sets of data that verify related but slightly different data points. If there's a change in the target application that affects the group of tests that share that automated test procedure, the change is made in one place. I've seen projects where these types of tests pay for themselves the very first time that they were run because one automated test procedure replaced hundreds of manual tests. In over 30 years working in the field of test automation, I've helped organizations automate hundreds of applications, and I can't think of one where data-driven tests would not save a significant amount of time and effort. Here's one example from the retail industry. Almost all of the transactions that need to be tested on a cash register, usually referred to a point-of-sale device, can be implemented as data-driven tests. Take the example of a sale. Processing a sale transaction through the POS follows a definite path, but there are many variables that need to be tested, including but not limited to the type of tender, different classes of goods to be purchased, discount, and taxes. In one project that I worked on, there were more than 100 variations on a sale, all being tested from one data-driven automated test procedure. Give a higher priority to tests where the test results will be the same every time the test is run, or where the results can be predicted at runtime as part of the automated test based on the test inputs and data lookups. This approach is a little more difficult to implement, but the trade-off is that the tests will be much easier to maintain. As the saying goes, necessity is the mother of invention. I want to share a technique that I devised when I was required to build a single set of tests to be run across different corporate banners and across the 50 states, territories, and Canadian provinces, where the different items for sale, discounts, state laws, and taxes would impact test results, such that the transaction totals could not reasonably be predicted in advance. The solution was to build a universal verification system. I created a standard schema for expected and actual results. During test execution, the automated test collected inputs to the test along with other data that was captured from application databases that could be used to calculate the expected results. I chose to store data in simple INI files because they were easy to write and parse. During test execution, actual results were captured from the target application and stored in the same format as the predicted results. A universal verification method was created to read the INI files and compare the actual and the expected results. For the purposes of this tutorial, the data has been significantly trimmed. Each of the 3 blocks represents a set of data used for verification. The predicted results on the left were captured and calculated based on test inputs and data lookups in the application database. During the automated test run, data was captured from both the virtual receipt and the electronic journal. When I used the same approach on e-commerce, I compared the shopping cart, the review order, and the submitted order pages. The universal verification method is not a complex entity. It simply parses the data from the 3 data stores and compares the values. It echoes the data back to the results file so that the user can review it and raise exceptions if a comparison fails. The project was a huge success because the tests could be reused in so many situations, and at the same time they were very easy to maintain. Because the verification was not at all tied to the target application, it required no maintenance. The original automation was written over 10 years ago, and I'm told that it's still in use today. While the original project was POS-based, I've used that same technique for web e-commerce, and I'm certain that it has general application anywhere that a lot of data needs to be verified. When prioritizing automation candidates, give a higher priority to tests that are executed regularly, because you'll be offsetting the high cost of manual testing. It's likely that the tests that are executed most frequently address core product features, and it's a good idea to automate them for the reasons that we discussed in part 1 of this presentation, namely, your company's reputation and its ability to compete. Tasks that are difficult to execute manually should also be given a higher priority. As noted earlier, the level of effort to execute manual tests varies widely. Tests that are difficult to execute manually include those where there's a lot of detail to verify and those that require either precise timing or a number of repeated actions over a long duration. Let's look at a couple of examples. Testing a software installation can be a daunting task. First, there's a lot of detail to verify. Did all the data files get installed? Were all the registry settings made? Were permissions set correctly? Were groups and shortcuts created? Was the application configured properly? This type of testing is error-prone because it's tedious on the one hand, yet requires acute attention to detail. I don't know about you, but I don't want to be on the hook for verifying a lot of detail when I'm bored. Then, all that verification has to be repeated for every platform on which the installation is supported. Controlling multiple client machines to ensure proper testing of concurrent transactions is also difficult to execute manually. It's hard to synchronize timing, and it can be difficult to repeat tests exactly when the problems are found. There are a few other general considerations to be made before you begin automating any tests. Perhaps more a consideration of when to automate rather than whether to automate is the stability of the application feature. Unless you have a lot of experience with test automation, it's not a good idea to attempt to automate a very unstable application. If the target application crashes frequently or does not behave in consistent ways, it might be better to wait until the application becomes stable to avoid frustration and lack of productivity. It's also important to get good control over the test environment before beginning to automate. While a manual tester can react to unexpected changes in a test environment, automated tests generally rely on consistency. Controls on source code changes and the data state of the test environment are imperative. Finally, it's important to think about how much future maintenance can be expected to keep a set of automated tests up to date. Give a higher priority to features that are expected to be stable over the life of the target application. Automated tests that require little to no maintenance will pay for themselves over and over again. In part 1 of this presentation, we started out by reviewing the reasons that we automate tests, then compared efficiency and effectiveness of manual and automated testing. That led us to our evaluation of good and poor automation candidates. As I noted at the beginning of this talk, choosing what to automate is a critical success factor that can make or break your next automation project. I hope that this presentation will have a positive impact by helping you make more informed choices. If you would like to learn more about how Xenix Software is reducing the cost of software testing by making testers more productive, visit us at www.xenix.com.